Hello. Hello. Good morning.
Hey, good morning, Vijano.
Yeah.
Hi, how are you?
Okay. So I am fine. Okay. So sorry for delay. So basically, lot of sleeping in this morning, so that's why I cannot wake up at this time. Okay. So no problem.
Okay,
We
you
will
are
start.
working late. You are working late, right? I think you are taking
Yeah.
late night classes, it seems.
Yeah.
So,
So that's why.
um,
Okay. Okay. So let's go start. So basically, today is
so,
our yeah.
yeah, so before we start, so you know, right? My on my side, it's late in the evening, almost night, right? Almost like now it's 10:45. So I think we will be able to make it only 1 hour
Okay.
from
Okay.
now.
Okay.
Okay,
No.
we will close
No problem.
1 hour and then
Okay.
we
No
will
problem.
continue.
Okay. No
Okay.
problem. Okay.
Yeah.
Okay, so basically today is our second number of days, but before
Yeah.
starting the second days, I also try to complete the some part of the first days, which not completed for this
Yeah.
first class.
Yeah.
Okay, okay, so let's go. I simply share my screen.
Hey, I think you are uploading this into YouTube, right? This video.
Yeah, I send you this also private link with you.
Yeah. Can we avoid that uploading that to YouTube?
Yeah, so in this time, it's my private channel, so YouTube channel. I can easily access. You will have to join, login with your Gmail account.
Yeah. So I will log in. So don't upload publicly.
Yeah.
You are not uploading this publicly, right?
Yeah. No. Okay, so but some previous 5 minute or 10 minute we also publicly available for that getting the advertisement so that the more people also will be more
Oh,
interested. But not full code, so it did
okay.
not complete public
Do
fully.
not upload full. In fact, even why I'm telling you,
Yeah.
you know, right? I'm working with the Levite, and we have some restrictions. If
Oh,
they find it, I'm doing something outside the organization, then it will be a problem for me.
okay, I
Okay.
understand. Okay,
So,
so
so
it
you can upload in your private challenge. Whoever has access to your private challenge, they can see this. But it should not be like if suppose they search with your name or my name and then it starts showing up, then it should not happen.
okay. So it
Okay.
also we can also take the another part of that. When we want to start this, you can simply rename your Google Meet name. Then it also better for that. Okay, so just
Yeah,
rename.
but my face is there. No? I have
Okay,
to stop my face,
yeah. So then it also better. You can
right?
also simply stopping the sharing your face, and then it's also better.
Okay.
Then we can easily do that. Okay, so some people have some restriction, so that's why we can
Yeah.
also do that. When you face any problem, simply change the name. Also did not share the face. Then it also better for them.
So
Yeah,
so do not share this publicly in
yeah,
YouTube.
yeah.
Do not publish it in LinkedIn because many of my colleagues are connected with me in LinkedIn. Okay, if they
Okay,
start seeing my face there,
yeah.
right? So it's a problem. So do not have you published this in LinkedIn? Not right. At least
Not
first,
not
first
not
one is
not
not published.
not
Okay,
public in the LinkedIn.
don't
Yeah,
do that.
yeah,
Don't do that.
yeah.
And if you have a private channel, you can publish there, but people should access with their Gmail ID or it should not be publicly searchable. Means
Yeah.
if people somebody search and they find my name or my face, it's a problem.
Okay,
Okay.
okay.
Actually, I should have taken a permission from my company to join this kind of the courses, but I'm joining on my personal capacity. Yeah, right. I'm
Yeah.
paying for from my pocket. So if they come to know, then it's a violation of the policy. Okay.
Okay. I
Please
understand.
don't
Okay,
share this
okay.
and not at all on the LinkedIn. Please no, don't share on the
Okay,
LinkedIn. Okay.
no. LinkedIn, I did
And
not
on
share
the
it. Yeah.
Google, YouTube also keep it in the private channel if you want. But people can access only when they log in and they cannot share it public. Okay.
Okay. I understand. Okay. Thank you.
Okay.
Okay.
Yeah.
So let's go.
Yes.
Okay.
Let's get
So
started.
okay. So now can you see my screen? Yeah.
Yes, I can see.
Okay. Okay. So first of all, I will try to discuss about that part. How you can easily filtering the attribute table. Suppose when you want to. So here I already previous class we'll try to discuss about that how you can easily imported the boundary shape file. Okay. And today we also try to
Mhm.
show you that how you can easily filtering the attribute table. Suppose you can see This is the one kind of boundary shapefile which I already uploaded in Google Earth Engine platform. So now I want to just filtering the specific boundary from here. Suppose you can see it is the total 64 district in Bangladesh. This shapefile is district boundary shapefile, all of those district boundary. So now I want to filtering the specific district from here. So for that, first of all, I need to import that. Simply click to the import. It will be imported. Default variable name is the table. If you want, you can change it. There is no problem. So I simply change the name. Suppose BD. BD. I can use any name. I simply put the suppose BD district. BD district. Okay. So now I want to display the result first. Simply use the map.addLayer function. And now I simply call my object name. Object is that I simply copy and paste here. And click the run. In this time you can see it's showing the layer 1, but it did not focus my area. So for that I need to use the another function, map.center object. Okay. And in this time my object name is the BD district. I want to put the zoom level such as 10 and click to the run. So now it directly focusing on my area.
Okay.
And now it's combining total 64 district in Bangladesh. Total 64 district in Bangladesh. Here we can get all of those.
Zoom level, if you can reduce the zoom level, it will directly.
So we can also reduce that. Suppose put here the suppose. So 5 and click to the run. Okay, so now we can see we can get this all of those district boundary in here. So from the district boundary, I want to focus only for the specific district. Suppose from this all of those district I need to only for the Dhaka city. So for that I need to filter it. So I simply take a variable and then suppose put any variable name, suppose ROI. And after that, first of all of those district boundary is stored in a variable. This variable is that BD district. I simply call this BD district and paste here, and then use a function. This function called filter. I use at the filter. So this is a common function for filter. After that, I simply use here that how I can filter. So I want to filter Earth Engine filter dots equal. EQ means equal. In this time, now arise a question about that what's equal what. So in this time, you can see here I simply click on here. Here I can get a attribute table from the feature. I can got a attribute table in here. You can see name 2. Okay. So this is the name 2. This is the column. This column exists all of those district name. In this time, I want to select name 2 equal Dhaka. Which district I want to need? I want to need Dhaka. So use the name 2 equal Dhaka. Okay. So I simply copy the name 2 from here. This variable name and just simply use the name 2 and then use the Dhaka. Okay. So in this time what happened, you can see I simply call the BD district because it stored all of those district boundary stored in here. So this BD district I want to filter. Then how I can filter? I want to filter higher name 2 equal Dhaka. Okay. So now this Dhaka boundary is stored in this variable ROI. So now I display this result. So let's go. I simply use the map.addLayer and also call the ROI. In this time I want to display the Dhaka and Dhaka is stored in ROI. Okay. So click to the run. In this time you can see we can get only for the one boundary area only for the Dhaka. In this time it's showing the 2 layer because I had the map.addLayer function 2 times. Okay. That's why I can got the 2 layer. So just I simply commenting this for better view. Simply click to the and also click to the run again. In this time I can get only for the 1 layer. I can say only for the 1 layer for the Dhaka. I also increasing the zoom level for focus at the center of the Dhaka city. Use here map.center object. And put this object name is that ROI and zoom level suppose 8 and click to the run. So now you can say I can get the Dhaka district boundary. This is the Dhaka district boundary. We can get in here. Not only for the Dhaka, any district. Suppose I need for the another district, suppose Gazipur. Simply write the name because the name to column is stored all of those district name. Okay, so I simply call here Gazipur and click to the run. So now it display the Gazipur district boundary. Okay, so now you can easily use this district boundary and make the different types of remote sensing analysis. Suppose you need this district for the suppose Rangpur and click to the run. In this time you can see it's not loaded. You can see I did not get the boundary shapefile because your spelling must be same with your attribute table. Okay, in this time this spelling will be RO. Okay, so previous time it will be showing the RO, and click to the run. In this time you can see I can get this Rangpur district boundary. Okay, but now at present time it also changed the spelling RA, but my shapefile attribute table has this name is that RO. Okay, so I need to use the same spelling, then it will be work.
So you open the shapefile in the other window that you are looking into the table and all, or you can see that here also because you uploaded that, right?
Yeah, you can upload it in here. From the
you already uploaded, right?
Yeah, already
so where
uploaded.
you are seeing where you are seeing the attribute information in which console or inspector?
Okay, in this time you can say I can get it from the information from the feature. Feature has stored all attribute table, but it has another problem. This problem is that this feature only showing the 10 item. You can see from the 0 to 9 we can get only limited the first 10 feature. Limited first 10 feature display. But suppose I need for the all of those feature because it total 64 district. Okay, so I need the 64 district feature. So for that you can simply print that. Simply use the print function, and I want to print that such as the BD district. Simply copy and then paste here. So now I can get all of those feature list in the console.
Okay, got it. It's computing and then it will show.
Yeah. So you can see here, go here and go to the feature. We can get the 65 all of this feature. I'll also get all of the information about this feature. Suppose you can see name to is that Parvotto Chattogram. Okay, now you can get all of the things name all of the attribute table information we can get as this. So basically this is the column and this is the information. Okay, this is the column name. Yeah, so this is the process. Yeah. So now we can easily filtering our attribute table using this process and also select for a specific feature. Okay, so now in this time Google Earth Engine has some another data set. Suppose some data set we can easily use and get this country boundary shapefile, as well as we can also get this suppose different without uploading our shapefile. We can easily get the different types of boundary shapefile in Google Earth Engine platform. Okay, so this is the one of kind of data set. The data set called that US data set. Okay, so US data set basically this data set provide you the international boundary polygon. So I simply click on here. You can see large scale international boundary polygon. In this time this data set we can got from the Earth Engine public data catalog. Okay, this data set provide you all of the international boundary polygon, and this data set provided is that United States Department of State Office of the Geographer. They have provided this data. And now we can easily use the data. We can get all of those, any specific country boundary we can easily get without downloading the shapefile. Okay, because it stored all of those shapefile already. So in this time I want to work with that. So first of all I need to import.
So you are importing without downloading.
Yeah. So in this time we are not downloading. We can get the data from Earth Engine public data catalog.
Okay. And but download option is there, right? We can download that.
Yeah, we can. Yeah, we can also downloading that from here. Suppose you want to create a shapefile and you can download it, so you can easily download it from here. In this time, without uploading shapefile, we can get the shapefile from Earth Engine public data catalog. So just simply click on the import. It will be imported and showing the table default variable name. Basically, this table stored the all of those country boundary polygon. Okay. So now this table I need to filter and select a specific country boundary. So for that, take a variable first. Suppose I put the variable name is the country.
Same thing, we will use the filter here.
Yeah. In this time we also need to use the filter. Yeah. So just I simply call the table because it stored all of those country boundary polygon. I just simply use the table and put here the filter function. Now define how I can filter. I want to filter Earth Engine dot filter dot equal. Now arise a question, what's equal what? I simply go to this table information sheet. Here you can see they already provide some option about this filter. You can filter using the country code, you can filter using the country name, and country name US recognized name you need to use. So I simply copy this country name, and then I simply put here this country name such as, and also put the country name equal, suppose put here suppose Bangladesh. And now I want to display the result. So put here the map dot add layer, and then put here this country. Yeah, this is my object. Click to the run, but it not focus, so that's why I also need to focusing. So see there the map dot center object, and object is that ROI not country. Okay, so I simply use there the country. ROI is the object is the country. So and also put here the zoom level, suppose 6. So now it displays the country boundary of Bangladesh. You can see you can get in here. Okay, so now you can easily work with this shapefile and work with different types. So not only simply put here the suppose all country. So put here the India.
But in this data, you will not have the district information in the Bangla.
Yeah, it's only for the country boundary polygon. Only for the
Only
country
boundary.
boundary.
If you are doing a country level analysis, right?
Then we need to use, yeah.
And if you want to do the district level or some other level, state level analysis, then you have to get into the other shapefile.
Yeah, but Google Earth Engine has other shapefile also available. Okay, so you can also I also show you this data set. Suppose I simply open that data set, browse the data catalog. Actually, when you click on the browse the data catalog, we can get all of those data sets. As you can see, I simply click on the suppose view all data set. There is a lot of data set is available for the different types of country boundary, district level, then also city level. All of those shapefile is available. Also different types of remotely sensed data set, remotely sensed data is available. Also all of those Landsat images are available, Sentinel, Modis. Okay, and different types of data set we can easily access from here and work with that. Okay, so you can see there is a lot of data sets, different data set we can easily got from here, as well as also, okay, I can say
which is highest resolution image you have seen
in Sentinel.
Remote sensing.
In the freely we can use here the Sentinel.
Sentinel.
Yeah, freely. But if you want, you can also use here the Maxar satellite image. But it you have also pay for that. For that part is
how much is the resolution for Sentinel?
Sentinel is the 12 meter to 10 meter distance.
12 to 10.
Yeah.
And for paid version, how much?
Paid version we can get the 0.3 meter.
Oh.
Yeah, and it's per square kilometer is that for that I think the 3000 Bangladeshi taka per square kilometer. For the Maxar satellite image.
3000 Bangladeshi taka. Okay.
Yeah, for per square kilometer. And, yeah.
But that is again is 0.3 meter only, right? So
yeah.
Are you going to go beyond even lower or higher scale, centimeters, or we have any resolution, any images available with that resolution, say 10 centimeter, 15 centimeter? Okay,
so it also possible, but I also work with for the Maxar satellite imagery for the advertisement for that. So that's why I also know about the Maxar and how, and also distribution about this Maxar, and also marketing about the Maxar satellite imagery. So that's why we can easily, if you want to need any types of satellite images like that Maxar, then we can easily got that for the whole world for the high resolution satellite. Yeah.
Whether we can get a centimeter level accuracy resolution, like 10 centimeter, 15 centimeter kind of accuracy.
Yeah, for the 10 centimeter, we can also use I think the spot satellite image that we can also use for that. Spot satellite, yeah, spot.
Spot, okay.
Yeah, spot. Spot is also available for that.
Where can I get that information here?
Okay, so basically, we need to for this we can simply go to their website, and there also have some contact email ID or info. We can easily get this information from this email ID. Or
can we then import that here in Google Engine?
Yeah, we can also import that in Google Earth Engine and also work with all of those function. We can easily work with that. Okay. you want to import
Okay.
this satellite image, then you can easily work with for the land use land cover, also get the NDVI, any types of remote sensing work you can easily got. Okay.
Mhm.
Okay, so also you can see
So,
here, yeah,
sorry, one more. So,
yeah,
but in the catalog, you will not find that information, right?
no.
This catalog is created by Google, so they don't have. But then, may not be today, but sometime later, you can explain me how to get the image from the external sources which are not there in the catalog.
Okay. So also, I think I
Okay.
already created the video about that for the Maxer. Maxer is freely we can use only for the 3 band. Okay, there are total 8 band they are provide, but freely we can use here the 3 band RGB only for the red, green, and blue. Freely we can use it, but when you want to buy that, then you can get the totally 8 band. All of the band we can easily get from here. Yeah.
But let's do that sometime later, not today.
Okay.
But
Okay.
we will get one free 3 band image V1.
Yeah.
I want to see how to import that image here in Google.
Okay. So I think here I already downloaded. Okay, I will let you show you that later. Okay. So now you can see here we can get also some the global administrative unit layer. So this is the one kind of data set which provide you the district or city level shapefile. Also you can see it also provided the also modes. Okay, so a lot of data set you can also use here. So the filtering process is the same. So suppose I click on here.
Yeah.
And now I can get all of the information about this data set. Basically this data set is the provided the FOA. Okay, so this data set you can get from here. So this is the data set link. You can simply copy that and also filter the data set. And how you can filter, you can get the information about that. You can see, you can put suppose you can use here the integer type GUL country code you can put here, then filtering. Also you can see UN country name. Okay, also you can see use the dips area, status, chef area. Also you can see administrative unit at first level. Okay, you can use this, simply copy that and put here this value. Okay, suppose name of administrative unit at the first.
Administrative level name is also there. So you can, instead of code, you can get it from the name.
Yeah.
Because most of the time we know the names, right?
Yeah. Name of administrative first level. So lot of process also you can see without shapefile, and which suppose which shapefile is not available, then we can easily create the shapefile in ArcMap software and also import that. Suppose more local region you want to for your research work, so this shapefile is not available, so you can simply digitize in ArcMap software and also import in Google Earth Engine platform, same process.
Yeah, but for that you have to go through all the process. You have to first scan the image.
Yeah.
Then georeferencing.
Yeah. Then digitizing. Then
digitization and all those things, and then create the shapefile.
Yeah.
Okay.
Yeah. So now you can see here we can. Yeah. Okay.
This is good information.
Yeah. So now, okay. So basically, this is our for the completing the first day's class. So now we can move to the second day. And second day,
first day is done.
Yeah, first day is done. Okay. But okay. So in this time, second days, we also try to show you that how you can easily filtering and displaying the satellite image, Landsat and Sentinel. Then also band combination I can easily use. Then export the satellite image from here and import the filter and reduce clip and display data in Google Earth Engine platform. How to make time series chart from the modis, export any shapefile from Google Earth Engine, and calculating any indices from the satellite images. Okay, so let's go about that. So first of all, this is the Earth Engine public data catalog. In this Earth Engine public data catalog, we can get all of those remote lessons data. We can also get the some also vector information from the Google Earth Engine public data catalog. And this Earth Engine public data catalog, we can get all of those. And this it's daily updating. Okay, this data set is a daily updating in Google Earth Engine platform. So that's why you can easily use for the real-time data from here. Okay. So now you can see here, this is the Earth Engine public data catalog link. Simply copy the link and go to that, or simply click on. You can see I already displayed that browse the data catalog. Then we can get all of those Earth Engine public data catalog. Simply click on here. Here I can get all of those public data catalog. So you can see this is the different types of climate, weather data, surface temperature, climate, atmospheric data, weather data. Also we can get the imagery, Landsat, Sentinel. Okay, mode is high resolution imagery. We can also get some, suppose NAIF, it's only for the available for the United States, only for the NAIF data set. Okay, it's very high resolution imagery. Okay, we can also get
high resolution. What is the resolution? Can we go inside?
you can see
resolution
this
how much?
resolution is that I think 0.6 or okay, so you can see this data set I think this set also
Yeah, it's kind of
0.6 meter.
Oh, okay, that's good.
Yeah,
0.6 meter means almost like
yeah,
1.5 feet.
yeah,
Yeah, almost like 2 feet.
yeah. So this is a naive data set. You can easily use for the unit data set. Also, you can see this is another data set for the planet SK set. Here, this data set you can also use for that. Okay, it also the same 0.8 meter resolution. We can get the data set, and freely we can use that. There is no problem. Also, you can see multispectral imagery for that, ortho imagery. You can also get from here, and this 2 meter resolution. Okay, so this is the free high resolution imagery we can easily access from here. It's only available for the United States. Another global is not possible for that dataset freely use. Okay, so now we can see here we can get the dataset, lot of dataset from here. Also, you can get the different types of train dataset, different types of DEM. Also, we can get the land cover dataset. Okay, we can because this dataset mainly derived from the Sentinel-2 or Modis. Okay, so now for the whole world globally. So from that we can simply analyze our for a specific region. Also, you can see cropland data, so we can easily get from here. Okay, other geospatial data we can easily get from here. Okay, so now
can you go back to the NAP data set again one more time? High resolution.
Yeah, so
that is with the NAP, right? NAIP.
where is it? Okay,
it was
yeah.
High resolution. Okay, so can you go here? Yeah.
NAP.
And so if suppose I select one geographic region, one state, United States, US state, right? This, for example, my Florida state.
Yeah.
So where can I see what is the date when the image was acquired?
Yeah, we can get it. Okay, so I will show you that this process also. Basically, image collection, Landsat or Sentinel or Modis, all of those image filtering process is the same. When you want to learn the Landsat, you can easily apply the same process for the NAP dataset, NAP image collection. The same process. Okay. So let's go. Okay. So click on the Modis. First of all, I will try to discuss about the Modis. So in the Modis dataset, you can see we can get a lot of product for the Modis. All of those product is the Modis, and for the all of those products is the same. When you want to work, the same process you need to apply. Suppose in this time you can see the net primary production, Modis land cover dataset, atmosphere monthly global product. Also you can see Modis band area monthly, and all of that is the global. You can see we can get the global data. Trap vegetation indices. Also you can see trap vegetation indices 60-day global, and this is the 500 meter, and this is the 1 kilometer. Okay, different types of resolution data so we can get from here. Also you can see the trap vegetation index is 60-day. Also this is the net evapotranspiration data set 8-day. Trap gross primary productivity. So lot of data set, land surface temperature. Okay, so lot of data set we can easily get from here. And when you want to do for the analysis using the data set, you want to display the data for the specific region, you want to export the data, you want to make the time series chart, all of those process is the same. Okay, so randomly I want to show a data set and try to show you this part. Suppose I want to work with for the data set and then try to make this map for using this data set. Basically this data set you can get all of the information when you can click on here. Basically this data set provide you the NDVI and EVI. Okay, so NDVI is the normalized difference resolution index and EVI is the enhanced vegetation index. Okay, suppose you want to need this NDVI, so NDVI is the mainly for the greenness of the any quantify the greenness for any specific region. Okay, so in this time I want to work with the NDVI and then create the NDVI map for any specific time period for my any specific region, and also make the time series chart about that. Okay, so first of all I need to import the data set in my code editor. Okay, so I simply open my code editor. Okay, so first of all here you can see I need to import the data set. Okay, so there is the two way when you want to import the data set in the code editor. One way is that you can see this data set. Okay, this dataset has a Earth Engine snippet. So basically, this is that unique ID. Okay, this is the unique ID for this dataset. Okay, only unique ID, and all of those dataset has a unique ID. So in this time, if you want, you can simply copy this unique ID from here and then paste in a code editor and give a variable name in here. So suppose put the variable name is that Modis and put the equal sign. In this time, this dataset is the imported in my code editor. So this is the one way. Another is that I can simply search here. So simply search here Modis, Modis and DPI. So now you can get this. You can see this data set I want to use in here. 250 meter resolution. This data set I want to use. Simply click on here. I can get also same information. Okay, who is the catalog page? I can get the information. I can got the same information also in here. Okay, you can see description, band, all of the things, NDVI, EVI, all of that I can get in here. In this time, I simply click the import. You can see this data set is also imported. Okay, this is the another way. So all of those data set, when you want to work, we can just follow the one way. Basically, we can import the data set code editor to the two way. Okay, so you copy the snippet and paste and give a variable name, or then simply search the data set in here and simply click the import. Then this data set is the imported. Yeah.
So basically, the for this one, the second one is the image collection.
Yeah.
When you already know what exactly you want to see, means with the Modi's code, right? Modi 006 and NDVI, whatever, right?
Yeah.
So when you know that, then you can use this. Otherwise, if you don't know direct what exactly you want to see, you can go to the browser, then select, and then click import.
Yeah. Yeah. So you can also get the information. Suppose you can get the code like this. Simply copy this ID. Simply copy this ID and paste in the search bar. Then we can also get the same data set. Also, you can see.
Yeah, correct.
Then we can identify this is the Terraphase analysis. This data set. Okay, so I import the data set. So suppose I want to use the second one and then simply remove the first. Okay, so I want to use this. Okay, so in this time my data set is the imported in here. This data set has a two band NDVI and EVI. I want to work with NDVI. So first I need to select. So use the select function and work with NDVI. Okay. So now we can check about that image. Suppose I want to check how many images are available for the whole world for the NDVI between this time period, year of 2000. I think this dataset provides the 2000 from 2023. Between this time period, how many images are available? I want to check it. So for that, I simply use the print function.
Okay.
And then simply call this variable name Modis and use the size function. And click to the run. I can get total 529 images between this time period. Okay.
529 images of what? Entire US?
No, whole world. I can get this whole world. And what is the duration? Okay, this duration is the total 16 days. Okay. So in this time, I need this image for the specific time period. Suppose I need only for the 1 year, or for the yearly rainy season, yearly dry season, a specific time period I want to need the data set. So for that, we need to use a function in here. So I simply use the same function in here. Use here the suppose filter date function. Okay. So filter date is a function. It filtering the specific time period. Suppose I need that.
One second.
Yeah.
So this on the console you got 529, right? Size.
Yeah.
So that means there are 529 images
are available.
So, are available. How I can see the list of images? What are the different images with the date?
Yeah, I also before
before we go to the filter.
Yeah.
I want to see the complete list.
Okay, so for that I can simply print that. Simply print only for the Modis without size. So now I can get all of those image time you can get from here. Simply click on here. You can go to the feature. You can see the first image is that 2018 February, and also you can get the last image. You can check about that 2023.
Okay.
Yeah,
February. 2nd
February. Yeah.
There is only one band image.
Yeah, only for the NDVI, because I select only for the one band. You can see NDVI.
Oh, okay. I got it now.
Yeah.
Okay. That's how we selected NDVI.
Yeah. So now I need. Okay, so from all of those images, total 529 images, Suppose I need from all of the image, I need only for the year of 2020. Okay, so put here this filter date function.
Yeah.
Filter date and check, put here the start date and end date. So start date, suppose put here 2020 1st January from, I put the whole year, so year of 2020 December 31. Now let's check about that how many images I want to get, and also get about that how many image acquisition time. Between this time, you can see I can get 23 images. Okay, so 23 images I want to check the feature. You can see first image is that 1st January, 17 January, 2nd February, 18 February.
So then that means every every 15 days they're taking money.
Yeah, 16 day I can get. So that's why this dataset called that 16-day global. Okay, because the dataset time interval is that 16-day. Some dataset you can also got for the 8-day, because this dataset is the 8-day interval. Some dataset you can get the 32-day. Okay. In this time, when you want to make the time series chart using this dataset, we can get the every 16-day interval time series chart. Because this dataset is the globally 16-day.
Yeah.
Okay, so now I can get this image from here. Okay, so in this time, I need to reduce this image collection. Okay, because in this time, from all of those images, I need to some calculation about that. From the all of those images, I need to create the average pixel value. Okay, suppose between this, because you can see in the year of 2020, all of those images is not captured at the same time. It will be captured for the different time. Okay, so different time it will be captured. In this time, when I want to make this NDVI map for the any specific region, it not capture at the same time. It will be captured at the different time. So that's why in this time I need to reduce all of those image collection. And basically reduce is a statistical function in Google Earth Engine platform. It will be calculated the average, it will be calculated the median, it will be calculated the standard deviation, it will be calculated the mode. Okay, so this type of result we can use using the reduce. So in this time I want to reduce this image collection and make a one image. Okay, and this image mainly provide you the information about the average pixel value, and this average pixel value is created from this total 23 images. Okay, so for that I simply take a variable suppose average NDVI. Okay, I want to reduce this image collection. So for that I simply call my 23 image stored in a variable. This variable name is the modis. Simply copy the modis and paste here. Okay, and use the function reduce function. Reduce is a statistical function. Then I need to define how I can reduce. I want to reduce according to the mean or pixel value, average pixel value. For that I simply use at the Earth Engine reducer dot mean. Okay, okay, so now it will be okay. It will be calculated the average pixel value and store it in this variable. Okay, so now I want to show, suppose use at the print function, and now I want to check about this average NDVI what I can got. You can see, simply copy and paste and click to the run. In this time I can get the image only for the one image. Okay, one band image. In one band image it's storing the average pixel value of NDVI. Okay. So now I
and it is showing the word, I think a file format, also JSON file format it is getting.
In this time we can get this file format is the TIFF file format. TIFF imagery. Okay, so let's say about that, display the result. So for that I simply use at the map.add layer, and you can check about our object. I want to show the average result. Okay, and you store it in this variable. Simply copy and paste and click the run. In this time you can see we can only further write the 3 line of code and we can get for the whole world NDVI map. Okay, so this is the power of Google Earth Engine platform, but this map is not colorful because we did not use the any visualization parameter. Okay, we did not use any visualization parameter. So in this time, this is the object. After the object we can put here the visualization parameter. First class I also discussed about that. So in this time I want to add the visualization parameter. Suppose high vegetation, what color I want to display, low vegetation, what color, medium. Okay, so for that they already provide a code for the visualization. You can see This is the visualization code. So I simply copy from this code from here and then paste in my code. All of those, you can check all of the data set. They are provide the default visualization color, but we can also change it. There is no problem. In this time, they make a dictionary. Okay. In this dictionary, they are defined the mean pixel value 0, max pixel value 8000, and also between this range, they are also make the color plated look like this. Okay. So in this time, I simply copy this variable name and paste after the our object name, because visualization parameter always put after the object name. This is the object, then put here the visualization name, and then we put here the our layer name. Suppose put the layer name is that NDVI map of. Okay, so we can put this, suppose world NDVI name map.
World NDVI is enough.
Yeah, then click to the run. So now we can get the very better result about the year of 2020 whole world NDVI map in here. You can see from that we can easily identify where the dense vegetation, where is the low vegetation. We can easily identify this type of place. Okay, and we can get the result for the and we can get the result for the whole world. Okay, within 1 second we can create this NDVI map for the whole world. Okay, but when you want to do for the using the ArcMap or QGIS software, it's not possible to do this type of analysis, because you need to download the Modis satellite image tiles by tiles, and lot of time when you want to downloading the Modis satellite image, it's the
we created one Modis image tile by, and they merge all the images together for entire world.
Yeah.
That's great. That's good.
Yeah. So now if you want, you can also export this satellite image for the whole world.
Kind of image, TIFF format image, but this one image must be in the gigabyte, or at least in megabytes, right?
Yeah.
So loading this image so fast is not possible, or like it requires very high processing system.
Yeah,
that's good. I understand this.
Yeah. So now we can get all of the things the cloudly. So that's why we need to download other things. Yeah.
Okay, so now say for example this anyway image is there. I just want it for Bangladesh or India.
Yeah, okay, let's go about that. We try to discuss about that anyhow. So in this time, we already discussed about that how you can easily import the shape file in here in the your asset.
Yeah.
Or we also try to show you the another way is for the US data set. Okay, so simply import the US data set and simply select your country bound specific country. Suppose I put the variable name, suppose for country,
yeah,
and then take the table, and this table I want to filter how I can filter earth engine filter, then equal what's equal what, put here the country name and put the country name, suppose Bangladesh. Okay, so now this Bangladesh country boundary shape file is stored in this variable. Okay,
yeah,
in this time this full image I can got in here for the whole world. From that I just need to clip. Okay, so just I can simply use here, suppose use here a clip function, because you can see average NDVI display the result whole world. Okay, so in this time just I simply use here the clip function, clip with country.
Okay, I got it.
Click to the run. In this time I can get the result only for the country boundary of Bangladesh. You can see I also need to focus the country. Suppose put here this
so you can use the
map dot center object and put here this country. Suppose 9. Any now I can get this result for this NDVI. Okay, not only for the so you can this time you can simply put this country name. Suppose you need the result for suppose Saudi Arabia, and click to the run. So now I can get the result. You can see Saudi Arabia for this year of 2020. Very less vegetation. We can get some only for the some vegetation in here. You can see. Okay, you can see. This is a vegetation. This is a vegetation.
It's all desert, huh? It's clearly showing the desert.
Yeah.
It's almost entire country is desert, huh?
Yeah. Also you can see. Now, first of all, you want to put here this region result for that Australia. Here this Australia. So now I can get the result for the Australia.
Yeah. Little good.
Okay.
I think you have that interpolation and extrapolation also in some in your list, right? We'll be studying that sometime, that right?
Yeah.
Good.
Okay. So you can see you can get the result look like this for the Australia in DVMF for this region year of 2020. If you want to need this, change the time period, simply change the time period, and you can easily get this result. For the any other time period, you can easily get in here. If you want, you need the suppose you need the data set for this lake of Chad. I simply suppose you can see this shapefile I imported. Okay, so now I want to need this result for this region. Okay, so for that I simply import the shapefile because I already the shapefile is already exist in my asset. So just I simply import in here, and then I simply you can see it showing the table 2. Okay, in this time I simply just commenting this line and use the same variable, suppose country, simply copy the country and then simply paste here the country. In this time I want to get the result for this my shapefile lake of Chad of like for this NDVI result. Okay, okay, so using the same code you can get the different result. Okay, just simply change the shapefile variable name or just change the time period, then we can easily get the result. For using the same code we can easily get the result for the different region. Okay, so basically for that we also provide all of the course practice code so that you can easily use this code for your own research work and you can get the result easily. And when you can practice, then you can easily develop all of the code one by one. Okay, just understand about the code and all of the same process. You can see in this time I want to show the dataset for that Modis NDVI. This dataset I want to use, but using the same process, you can also try to for the other datasets such as EBABO transportation dataset, also the gross primary productivity dataset, LST dataset. So all of those datasets which are available in here for the Modis, you are applying the same process all time. Suppose Modis live area index, you want to work, just simply click on here and get all of the information about the dataset. Also you can get this time period about the dataset. Also you can see artisan snippet. Also you can see the 5-minute resolution. Also you can see the band, which band you want to need. You can see, just simply copy the band name and work with that. Okay, but in this time we also try to discuss about the another things. Okay, basically this vegetation canopy. Okay, it will, okay, in this time you can see, in this time we can get the map look like this, but this map has a problem. This problem is that when I click on the inspector tab and click for the any specific region, then I can get the result. In this time it's showing the world map NDVI because I want to use here this name. Okay, you can change it any name, there's no problem. Suppose put at the lake of, yeah. In this time I simply click on the inspector tab and click on this map. You can see what the result I can got. I can got the result 3972 pixel value. Click on here, I can get the result 4000. So in this time I can get the result because this dataset is not reprojected. Okay, this dataset scale value is not reprojected. Okay, so in this time anyhow I need to reproject the scale value and then try to make the map which including the NDVI range within -1 to +1, -1 to +1, because all of the index, if you want to check the suppose NDVI range value, this NDVI range value all time within the range -1 to +1. Okay, -1 to +1. So in this time we need to the result within this range, then we can get the perfect NDVI map. Otherwise it's not a perfect NDVI map. It's showing the result 4000, so that's why it's not a perfect NDVI. In this time how I can read how I can reproject this scale value. Okay, so there is a lot of way, but easiest way is that we need to just multiply with the scale factor. Okay, and here I can get the scale factor. This scale factor I can got in here. You can see which data set I want to work. I simply open the data set again. Okay, this data set, yeah, so I simply open that. You can see here. Okay, so oh yeah, you can see that this data set is scale value. Okay, scale value, this is the scale value. Okay, In this
Okay.
time, I just simply multiply with my scale value all of those images. You can see here I can get total how many images I can got in here. Okay, I check it again. Just simply print that modis.
Modis.
Here I can get, you can see total, I think 29, yeah, 23 images I can get. Okay, in this time, this 23 images I need to multiply with this scale factor. Okay, this 23 images I need to multiply with my scale factor. Okay, scale factor is that 0.001. When I want to use that, then I can get the reprojected value. Okay, so for that, in this time, 23 images I need to have in here. In this time, I need to multiply all of those images at the same time. Okay, suppose you can see, you can get the randomly all of the images you can get. So you can see first image, this is the first image ID. Okay, if you want, you can simply copy this ID and multiply. You can also copy the ID and multiply. You can also copy the ID, multiply, but it takes some time. Okay, so I need to reduce this time and then we can just multiply. So for that, we need to apply the function concept. So function, we will already discuss about that, how we can easily create the function, and this function will help you all of the multiplication, all of the images with the scale value at the same time. Okay, so in this time we are using at the concept of the function. Okay, for the function we need to just take a variable name. Suppose variable name is the scaled NDVI. Okay, and create a function keyword and put the element name, suppose image. Element in this time I take only for the one image, but it has total 23 images. I want to get only for the one image. Okay, so I want to apply this multiplication with the one image and then copy the properties, and these properties I spread from this time period, between this time period, because between this time period we can get only for the 23 images. Okay, so let's go. I simply put it at the curly bracket and put my argument. In this time I want to return which image I want to put in here. This image I want to return, it will be multiply with 0.0001. Okay, so this image I return, so that's in this time this image multiply with this scale factor. Okay, in this time I want to put only for the one image, but I have also rest of the 22 images. For that I need to copy these properties. You can see when I want to multiply with this image, then it create the one new characteristics or one new properties. So these properties I want to apply all of those images which are available between this time period. Okay, so for that I simply use a function. It's the copy properties. So I need to copy these properties. So copy properties. This copy properties mainly I want to copy from the image. Okay, and apply these properties between this time period. So that's why I simply use.
We are using printer again, printer date.
No, because I already we can put the time. So my system, this system I already put the time. So that's why I simply put here the system time start, and also put here the system in, yeah, system time. Okay, so this is my function. Okay, so you can say I again explain. I take a function variable name, take a function keyword, put the element name. I take only for the one element. This one element I return, multiply with my scale factor. When it will multiply, it take a new characteristics. This new characteristics I want to copy, so that's why I simply use the copy properties, and I copy from this time period. So that's why I simply put at the system in. Okay, very easily we can get. In this time, this is my function. Okay, and this is my collection. Okay, basically this 23 images is stored in the modis variable. Okay, and this is my function. Okay, in this time I need to make a connection with the modis and this function. I need to create the connection. In this time you can say there is no connection. It is a totally separate code, and also this is another separate code.
Yeah,
Okay.
yeah.
So in this time I need to make the connection about that. So that's why I simply copy the modis variable and paste here. Okay. And for connecting, we are using a function, this function called the map function. So use at the map and use at the parenthesis start and also close the parenthesis. Basically, this map function is connecting which function I created with my whole collection 29. Okay. So now this scale and DVI, you can check how many images in scale and DVI. So print the scale and DVI, we can get the same
You have
number.
23 images, but scale will be reduced.
Yeah.
I mean,
Click to the
there will
run.
be scale.
We can get the same number of images in this time also. But in this time, this 23 images for the scale and DVI, this 23 image is the represented this scale value because I multiply. Okay.
Yeah.
So in this time, all of the work I want to do for the scale and DVI. So now I use the 23 image and create the average pixel value and also clip with that my shape file. We can do the same process. So simply copy the scale and DVI. Sorry, scale and DVI simply copy and then paste here.
Replace that with modis.
Yeah. Then reduce it and click. Okay, all of this will be same. Then click to the run. In this time, you can see what I got. In this time, I can totally get the white color background because we also need to change the mean and max pixel value. In this time, I can get the range. Mean is the -1 and max to the +1. But in the display, it's showing this wrong. So in this time, I simply put here this -1 and max up to +1.
Same what scale you are seeing there.
Yeah. So click to the run. In this time, we can get the some difference. In this time, it will be different the result, but this result is more convenient. Okay, because you can see this result showing the water body as a green color. So that's why I simply change it also. For that, I simply put here the suppose mainly in NDVI, the negative pixel value will display the result about that water body. Okay, and high positive value is display the result for the vegetation. So and also medial it will be showing the barren land or other things. So for that, I simply use here the blue color for the water body and also put here the white color, get at then blue color pixel value and put here this green color. Okay, then display the result.
So instead of try to use the brown so that it will represent the desert.
Yeah. Yeah. So it totally depend. Okay, you can use the different types of color. There's no problem. So in this time, you can, if you want to check the result for the Saudi Arabia, then you can also get the better idea about that. So simply out here the result for suppose. Okay, so in this time I put the lack of chart. So I simply remove this country and also open this new. I simply put here this suppose. Put here this suppose. And click to the run. So in this time here you can see I can get the result look like this. Okay, so this is the cropland in here. So this we can get some vegetation in here. You can see. Okay, not only for that, after creating this type of map, we can easily download and create this map. You can see here. Here I already created some map about this. I simply suppose you can see this is the map for the NDVI, and this map we created in Google Earth Engine, and finally display the map in the ArcMap software for showing the results such as water body. All of the things we can easily get. For the water body, we can get the low level pixel value of NDVI, negative pixel value, and high vegetation. I can get the high level for the dense vegetation. You can get the high level. Okay. So from this we can easily download the tip images and also create this type of map in ArcMap software, QZ software for our research paper or our presentation work. Okay. Okay, I'll try to show you this how you can easily do that. That is no problem. Okay. Okay, so this it's only for the cropland, agriculture cropland classification. Only for this. How much area is available for this region, the cropland. And you can see this is a SAVI map, SAVI soil adjusted vegetation index. We can easily create it. So all of this map we can create it from the Google Earth Engine platform. and then simply download this type of. Okay, so I simply open that.
So we can also do the change detection, right? Yeah.
For NDVI.
Anyway,
Yeah, it also possible. Here I already make the video in my YouTube. Okay, you can see. Okay, so I simply charts and then try to show you this video. Yes.
I think I have seen that video, but
Yeah.
it was incomplete because you are not fully uploading that, right?
Yeah.
You are uploading only some part of that video.
Okay. Okay. So I'll just share with the code. Then you can easily do that. So for the NDVI change detection for the different time period. Yeah. Yeah. You can also do that. There is no problem. Yeah. Okay. So in this time, I can get this image look like this. For this now, we can easily export this image. And before the starting the export, I also try to discuss about the satellite image. How I can easily do that, because exporting process is the same. When you want to export anything from the Google Earth Engine platform, this operation, this function, all of the things will be same. Okay, so let's go about our next slide and try to discuss about the satellite image, how you can easily filtering. Okay, in the meantime, you also try to do for your own self for rest of the other data set for the modis. Okay, rest of the other data set, you can choose any randomly, take any data set and also try to display the data set. Okay, suppose you want to work with the evapotranspiration, simply click on here and then you can get all of the information about the evapotranspiration. Also you can see the evapotranspiration also has some scale. Okay, so when you want to work with the total evapotranspiration, you also need to multiply with all of the image with this scale value. Okay, so you also try to do for this own self and then if any problem you can try to discuss. Okay, so in this time, this is the modis part. All of those modis you can easily do for this using the same process. Okay, so in this time we talk about the Landsat image. How can you easily do that? I click on the Landsat. So here I can get all of the information about the Landsat image, such as Landsat 9.
It's already they were put straight for me. So we have to stop because I have to start early morning tomorrow.
Okay, so early morning tomorrow is not possible.
No, I have to start early morning, so I have to sleep now. It's already 12, 11:45 India, right? Locally.
Okay. So from the Landsat, we also try to discuss the another for the next week about that.
Yeah.
For the
Monday?
Friday.
Next class is Monday, right? Monday. I mean, you are Tuesday morning.
Yeah, Tuesday morning for me. Yeah, Tuesday morning. For
Yeah, you are Tuesday morning. So that will be next class. We will start from the Landsat.
Okay, from the Landsat, we also try to discuss. In the meantime, I'll send you all of the recorded. I'll also send you the practice code. You can also practice all of the other data set. Okay.
Yeah. That. Thank you. Thank you. And have some enjoy your weekend and have some personal time as well.
Okay.
And don't just go for the trainings. Okay. I know this is your passion, so you like doing the trainings.
Yeah.
But yeah.
Okay. Thank you. Okay. Thank you.
Yeah. Okay. Thanks.
Okay. Thank you. Good night.
Have a good
Yeah.
day.
Okay. Thank you. Okay. Have a good night. Okay. Bye. Okay. Bye.
Thank you.